Okay, so now we start talking about the Pythagorean theorem. Now to review what the Pythagorean theorem is, it only applies to right-angled triangles. That means they're triangles that do have a right angle inside of them. Both these examples have this small square box that's within the triangle. That means that there is a right triangle, also known as a 90-degree angle, inside that triangle. So as you can see, there is a couple sides in the right triangle, 3 sides. The hypotenuse is the longest side on the triangle and is always opposing of the 90-degree angle. Why? Because the sum of all angles in the triangle add up to 180, and if one of them is 90, the other 2 angles have to be less or smaller than 90. Therefore, the largest angle is 90 degrees. So 16 would be the hypotenuse in this case, and C would be the hypotenuse in this case. Now review what the Pythagorean theorem is, that is a squared plus b squared equals c squared. So right here, we're just using the formula to find what c squared is. But we want to find what c is. So we just take the square root of both sides, so you get the square root of a squared plus b squared equals c. So I plug in my values. 15 squared plus 12.3 squared is, when you add them together in there, is 376.29. Yet c equals 19.4. We're supposed to round the nearest centimeter. Because it's less than 5, we round down. So our answer is 19 centimeters. Now in this case, we have the hypotenuse of 16 meters, and we want to solve for one of the sides. But if a squared plus b squared equals c squared, then c squared equals a squared plus b squared. And we can actually find, let's just call this b. So b squared, or b equals the square root of c squared minus a squared. So what you have to do is b equals the square root of 16 squared minus 10 squared. So b equals the square root of 156, because 16 squared minus 10 squared is 156. And you get b equals 12.48. Round that down because it's less than 5, so you get 12 meters as your answer right here. Now let's see this example here for the next question. This one says, Marshall leans a 6-meter ladder against the wall. Okay, let's call this the wall. Okay, the base of the ladder is 1.5 meters from the wall. How far out the wall? So let's have this ladder that's against the wall. And we know it's 6 meters. And we know the base of the ladder from the wall is 1.5 meters. So the dotted line is 1.5 meters. So to draw this as a right triangle, we see this, right? This right triangle, this is the wall right here, okay? We know the ladder is 6 meters and this is 1.5 meters. And what it's asking us is how far up the wall will the ladder reach, okay? So to do that, we're basically using the Pythagorean theorem, which is again is a squared plus b squared equals c squared, where c squared is our hypotenuse. In this case, we know the hypotenuse, that's actually the length of the ladder. So to find, we call this A or B, it does not matter. To find one of these sides, I'm just going to rearrange for either A or B. So we know A equals c squared minus b squared, all square root of that. So let's substitute the values in. Let's go to the square root of 6 squared minus 1.5 squared. So 36 minus 1.5 squared. Okay. Decimal, that is 33.75. Take the square root of 33.75 in your calculator, you get 5.8. So that means, and a therefore statement, therefore the ladder reaches 5.8, put a meter there, up the wall. So we found this last, how high up the wall? That is 5.8 meters. That would be your answer for that question. Now the next one, on his way to school, Abdul cuts across a vacant lot that measures 110 meters by 55 meters. He walks diagonally from corner to corner. One day a fence is built around the lot and he has to walk around. How much farther does he have to walk? Okay, so let's try to rationalize this right here. So on his way to school, Abdul cuts it across a vacant lot that measures 110 meters by 55 meters. Okay. He walks diagonally from corner to corner. One day a fence is built around the lot, and he has to walk around. How much? So let's find out what the hypotenuse is right now. He usually cuts across, okay? And we go C equals the square root of a squared plus b squared. These are two sides, right? Because this is a triangle right here, the right triangle. This is one side, this one side. I want to find the hypotenuse. And what we have to do equals the square root of 110 squared plus 55 squared. So what we have is 110 squared plus 55 squared, square root of 15,125. Okay? That to the power of 1 divided by 2 equals 122.98 meters. But that's not the answer to the question. The answer to the question is you want to find out how much more he has to walk if he goes this and this, right? If he has to walk around. So 110 meters plus 55 meters, all that equals 165 meters, okay? So 160, this is virtually what we got here is 123 meters. So what we get is 165 meters, subtract 123 meters, equals 42 meters. What is 42 meters? It's the additional distance he has to walk. So he usually cuts across, or the hypotenuse of this triangle. This triangle looks like this, right? The right triangle, right? It's 110 meters by 55 meters. Okay? Usually he walks across. But now, across diagonal, now he has to go around. So you go 110 plus 55, which is 165. The difference between that and the hypotenuse is how much extra distance he has to walk now. So 165 subtract 123, because this is rounded, 122.98 is about 123, is 42 meters. He has to walk 42 extra meters.